Let's talk now about um, isomers of alkenes. Have a look at these two alkenes in front of you. Each of these two alkenes has four carbon atoms, 1, 2, 3, 4, and 1, 2, 3, 4. So, and the double bond on carbon number 2, so both of these are called 2-butene. There is only one difference between these two, which is the arrangement of the different substituents on the sp2 carbons. So for the first compound here, if you see that there is the methyl group is at the bottom and the hydrogen at the top, and for the other one, the methyl group in the same side as the other methyl group and the hydrogen the same side as the hydrogen. While for the other compound, the both methyl groups are on opposite sides for the in relation to the double bond. Are these two equivalent to each other? Are these two identical? Actually, the double bond, we know that there is no rotation around this double bond. This is why these two are not identical. They are completely two different compounds. They are called isomers. And we give them a prefix. One of them is called cis, and cis here means that the two substituents are on the same side. And the other one is trans, where the two substituents are on opposite side. Before we discuss the cis and trans, or what we call E and D for the isomers of alkene, let's first have a look at isomers. So what are isomers? Let's learn about isomers. So isomers are basically compounds that have the same molecular formula, but they are different. So they all have the same molecular formula, but they are different. Depending on what kind of difference is there in the structure of these, we can split them into two categories. The first one is called the structure isomers, and from the name that means they are different in their structure. And the other one is called stereoisomers. And the word stereo means they are different in the arrangement of the atoms or the group in space. So it's different. There's a difference between structure isomers and stereoisomers. Stereoisomers can still have the same structure, but the arrangement of the group in space is different. Structure isomers, they are completely different compound. So let's have examples and see what are the different types of structure isomers. So structure isomers, there are three types of or three classes of structure isomers. The first one is chain isomers. Chain isomers means that the compounds, they different compounds, they have the same molecular formula, but the carbon chain connection is different between one compound and the other. An example of that for compounds that have the molecular formula C5H12. So we can have pentane as C5H12, and we can have 2-methyl butane, and we can have dimethyl propane. So as you see here, there is a difference in the chain connection. So the methyl butane is also called isopentane. It's the same compound, but they are completely different. And if you see here, they completely have different physical properties. So the boiling point between them is completely different. They are completely different compound. The arrangement of the chain is different, and the physical properties is also different because they are different compounds. This is the chain isomers. And then there is something called the position isomers. The second class is called position isomers. From the name position, that means there is a certain group, functional group here, and the position of the function group is different. So let's have an example. So C4H9Cl. We can have one chloroputane and we can have two chloroputane. So the functional group is the Cl here, and in the first compound it's in position number 1, in the second one it's in position number 2. Both of them are butane, and the functional group has different positions. So this is why they are called position isomers. Again, they have different physical properties, and they can also have different chemical properties. So they can react differently, although both of them are have the same functional group, but they can have different chemical properties as well. The third class of the structure isomers are the functional group isomers. Functional group isomers means that the functional group itself is different, not the position. Okay, so it's a different functional group. Let's have an example to that. So C3H8O, we can have propanol, one propanol, and we can have methoxyethane, or we can call this methyl ethyl ether. We know that there is something called the ether functional group when we talked about function group, when we talked about how when the oxygen is connected with two R groups or two alkyl groups, then it's called ether. So we have two different functional group here. We have alcohol and we have ether. Both of them have the same molecular formula, but they have different functional group. So these two are completely different. They have completely different physical and chemical properties because the functional group now is completely different. So they are the even different categories of compound. This is the last category or the last class of the structure isomers. So what about stereoisomers? Stereoisomers, they still, because they are isomers, so definitely they have the same molecular formula. Not only that they have the same molecular formula, but they have the same structure. So the same functional group, the same chain connections, everything is the same. The only difference between the stereoisomers is that the arrangement of this group in space is different. So there are two types of stereoisomers, and we are not going to discuss all of that in details. For the chemistry student, we will discuss stereoisomerism and stereoisomers in much more details later in the course, but for the chemical engineering students, this is just what they need to know. They don't need to know too much about the stereoisomers. So stereoisomer, there are two categories as well, or two classes. The first one is called conformational isomers, and the second one is configurational isomers. What's the difference between these two? So conformational isomers, when the isomers can interconvert easily at room temperature. That means that one isomer can change into the other one at room temperature easily because it's so easy to change. But configurational isomers, they do not interconvert. So they are completely different compounds. They cannot exist together at the same time. And if they do exist together at the same time, then we have two compounds, not one compound. One of the examples of the conformational isomers is the conformers of alkane that we talked about when we talked about the conformation of ethane. Um, when we talked about the conformation of alkanes, where the different rotamers or conformers of ethane come from the rotation around the single bond between the carbon and the next carbon. If you remember, we talked about the eclipsed form and the staggered form. Or eclipsed rotamer and the staggered rotamer. So if you don't remember, please go back and watch the video I posted before on the last lecture about the conformers of ethane.